for TCP UDP, let's make a recall, right? So it's back to OSI reference model. It's a transport layer protocol. TCP/IP also transport layer protocol. And then we need to know what it is. What is their job? Because during on the chapter number 2, we mentioned transport layer function is to build a connection, right? Build a connection. So the main purpose of TCP UDP protocol is the function is to provide connection-oriented or connectionless service, right? Familiar, right? Already mentioned. And maintain, if you build a connection, for example, TCP protocol, if they build a connection, you need to maintain the connection before the communication is over, right? The sequence is build a connection, maintain the connection, send the information, and sending the information, and retrieve or tear down the connection. This is the sequence. The most typical use of this protocol is FTP. You may, if you already use FTP, you will say when you use command to visit some FTP, firstly you got connected into that FTP server, and by then you didn't download anything, right? You didn't download anything. That means your connection is built, but without any data transmission. And when you download something, that data transmission. And finally, you will log out. When you log out, that means the connection is teared down. So this is what connection is, right? What the connection do. And I divide the application layer data into segments and encapsulate them, of course, right? They add layer 4 header, so that's what this sentence means. And implement multiplexing, transfer data reliable, implement flow control. This will explain that on TCP part. So here is the main function of transport layer protocol, and then TCP. On the whole, we will learn this chapter by compare TCP against UDP. So for TCP feature, we need to remember all the information on this page, all the information, because UDP just have a partial function or shared a partial common function with TCP. Some function is TCP only. So we need to tell the difference because this is the key point in the exam, right? Let's take a look. Three-way handshake. So here we need to remember 2 figures, 3 and 4. Three-way handshake to build a connection. 4-way handshake to finish the connection. 3 and 4. Right? Firstly, TCP build a connection. UDP does not. And TCP use 3-way handshake to build a connection. 4-way handshake to tear down the connection. Right? And port number. We will see that in the next picture. Right? Because network layer protocol, IP protocol, use protocol number to tell the upper layer, difference between upper layer protocol. And for TCP, you use port number to distinguish the difference between application layer protocol. Here, application means TCP/IP application, right? Just we take a look at the next picture. Because they have a different port number, TCP could recognize different application. That means multiplexing, right? Checksum, arrow check, right? To check whether this segment, this logical segment, is correctly transmitted or not, right? Sender send the TCP frame, send the frame with TCP header with a checksum, and after receiving, receiver will check the checksum is correct or not. If not correct, the frame will be dropped and retransmit. So this is checksum. And port number and the checksum is common with UDP. UDP also have these two functions. And acknowledgement, right? Because TCP build connection, and after building the connection, every data transmission have an ACK number. This is TCP only, right? Sequence number, TCP only. Every segment has a number, right? And when some sequence is lost, it can have the retransmission, right? Sliding window flow control. We already know transport layer have flow control, but only TCP. TCP have flow control. The method will be taught later. Right. TCP encapsulation, TCP header, we take a look. Firstly, TCP header is a layer 4 header. So if this is the data, this is the payload, this is layer 4 header, this is layer 3 header. So this will be called logical IP packet, and this will be called logical segment, right? This is a review. It's a review. And for TCP header format, is have a source port and destination port, because compared with IP address, right? On layer 3, IP have a source IP address and destination IP address to distinguish the packet path, the path of a packet transmission. And on layer 2, they have a source MAC address and destination MAC address to distinguish the layer 2 transmission. TCP on layer 4, they have a source port and a destination port to distinguish the unique connection, right? Sequence number, TCP only, right? And this flags, actually we will see these flags during we teaching the workflow of TCP. We will mention this later. Window, that's the transmission window. So TCP could using the window size to control the flow, right? Checksum, Persian pointer, as you could see the meaning on your textbook, right? This is not the key point. And on this one, TCP UDP port number. So we also see this structure, right? Layer 2, IP protocol use protocol number to distinguish the upper layer. To distinguish different protocol. For example, mentioned ICMP is 1, TCP is 6, UDP is 17, OSPF, we will learn it later, OSPF is 89. So they all based on IP layer protocol. For TCP and UDP, they use port number to distinguish different application, right? And all this number are required to be memorized, right? This is required to be memorized. Every one of them. This is the key point. Okay, so this is the structure of TCP and UDP. So we see the structure, right? Application layer, encapsulate, pass to TCP to build a connection, pass to IP to find a path, pass to network interface layer to find a MAC, to find a device and to send it out, right? And 3 handshake and 4 handshake, 3 handshake and 4 handshake. So 3 handshake to build, to establish the connection, and 4 handshake to tear down the connection. So this sequence is how to build a connection. For example, A and B already find each other through the IP network. They already know the IP address, and they sign the segment to build TCP connection at first. So host A, positively, host A send a TCP segment with the flag SYN. That means, hey, I am a TCP. And I am a host A with I want to build a connection with you, and my sequence is A. I'm using the TCP scene header to connect with you, and my sequence number is A, right? This is the first handshake. And then host B received and also send a SYN SYN TCP segment, and with its own sequence. My sequence is B, and I confirm your sequence. So ACK is A plus 1, and then host A confirm again, sequence A plus 1. So my sequence A plus 1, right? And I acknowledge, I confirm your sequence B plus 1. So we can see after the 3 handshake, they build a connection. And how to see this? How do you see these numbers? Sequence and ACK. 2 sentences. Firstly, ACK. ACK just confirmed the last segment from the opposite side. So that means it always will be the number plus 1 of the opposite side of the peer, right? For example, this A, so B is A plus 1. So for this one is a B plus 1, right? Always the peer's sequence plus 1. And for this sequence, it's my sequence. It's always my last sequence plus 1. Right? So this is A plus 1. This is A. My sequence plus 1 here. ACK is confirm yours. So it's your sequence plus 1. Right? This is how we build a connection on TCP. And how we terminate it, how we tear it down. So they use 2 more flags. It's a TCP segment with fin, F-I-N. That means I want to terminate one connection with you. So FIN sequence is P. And here, the ACK flag, ACK is P plus 1. So the flag is important. During the connection building, is all SYN, but ACK is fuse. This is fuse. But during the termination of connection, they use 2 kinds of different flags. One is fin, F is ACK, right? They all have their own fuse, sequence and ACK. Don't be confused about this. This means the flags in the header. Flags in the header. Let's take a look again. It's in here, right? Flags in here. Okay, so the 4 handshake, fin, sequence is P, ACK, P plus 1. Right? Always confirm yours plus 1. And then my sequence is Q, and ACK is Q plus 1. So that's simple, right? 3 handshake to build a connection, 4 handshake to terminate the connection. Remember that. And then transmission acknowledge, how to confirm the transmission, data transmission during by TCP. By here, the last page, we already built the connection. And then after building the connection, the data need to be transferred, right? Need to be transferred. So during the data transmission, right, is the second stage. First stage is building the connection. The second stage is to transmit the data. So during the data transmission, it's also have the acknowledge. So it's like this. For host A sending the data with 4 data length with 1K. And if the host B receive them all, the ACK is the last number, is the last sequence plus 1, because here is 3,000. The length is 1,000. So the last one should be 4,096. So ACK is 4,097, right? And data will be sent again from the 4097 and with the same length. So this is the acknowledge of the data that with a successful receive, right? If not successfully received, they need a transmission. The host B actually will send ACK with the one that he required to retransmit. For example, if the second data is missing, so the ACK is the last of the first segment of data plus 1. So that means I already missed the second one. Please retransmit. Right? This is the this is a retransmission signal for host A, and host A will retransmit the second data only, and then ACK for the last data, and normally send the data again. So this is retransmission, right, due to timeout. So, oh, this is the transmission due to timeout, right? That means the second data didn't reach to host B due to timeout. So this is this workflow to retransmission. And about flow control, sliding window, how to express how much data I want to receive from you for one time. So they use sliding data. So here there is another field called window, W-I-N, win. So for example, host A sending 4 data at once. So host B received them all. So the ACK is the next one. That means I receive them all and require new data, right, continuously. And then with a new parameter window down to 2K, 2000, and we can see the difference happens, right? The host A recognize and send the data in unit of 2, right? This reduce the window size. And ACK, window still 2000, still by 2. So this is the how TCP do flow control by changing the sliding window. Finally, UDP. So UDP we compare with TCP. The header, the position of the header is the same. Also, layer 4 header, but you can see the header format is pretty simple, right? Source port, destination port, length, checksum, and data. There's no flags. There's no flags. There's no window size. There's no let's take a look. There's no flag, no window size, no sequence number, no data offset, right? Urgent pointer also none of urgent pointer. So compare with TCP, compare against the TCP, you can see UDP encapsulation is pretty simple, and by using UDP, only know source and destination port. So the data could be, the payload could be transmitted immediately. So the advantage is very quick, no latency. But the disadvantage is because of no confirm, no acknowledge, and without retransmission, without sequence. So the reliability of UDP is lower than TCP. So, and another important point is to remember the common parameter, common fields that UDP and TCP have. Length, source port, destination port, checksum. They have this in common, but others it's not in common. So the TCP only fields we need to remember. Right. Comparison of TCP and UDP. Right. We take a look again. Connection oriented is TCP. Connection is UDP. End-to-end connection. No connection. Encapsulation. Right. Have segment, have sequency with, and encapsulation application layer data into datagram and with port numbers. This is the same, right? But there's no sequence. TCP has sequence, UDP have no sequence, right? And data retransmission, because TCP have sequence, so TCP could do acknowledge and retransmission, but UDP could not. Flow control, TCP have windows, sliding windows, could do flow control, UDP could not, right? This is the difference between them. And you will ask, oh, so if UDP is not that reliable, could not do retransmission, what kind of protocol, what kind of application will use that? We use UDP. So actually, there are a lot of kind of application which require the rapidness of transmission. by using UDP protocol. Then for the reliability part, the application layer or the network layer will, or usually the application layer protocol will take care of reliability all by himself, all by application layer protocol himself. That means if you use UDP, the application layer protocol better have a reliability control method, right? Mechanism. But if you use TCP, TCP will guarantee the reliability. So the application layer protocol will be relief, right? So okay, so this is for TCP and UDP chapter. So if we take a review, so we know their difference on the they are all layer 4 protocol. They are common points and differences, and we know TCP build a connection before transmission, and 3-time handshake to build a connection, 4-time handshake to tear down the connection. Right, these are important information. Also, the common fields of TCP and UDP.